Welcome to Chemistry_Studio_ the intellectual odyssey rages on. Are you ready for another exciting chemistry video? But first like, share and subscribe to my YouTube channel. Hello and welcome to this video on Buckminster fullerene and graphene, two of the most fascinating materials in chemistry. In this video, we will discuss their discovery, structures, and properties in detail. Let's start with Buckminster fullerene, also known as the Bucky ball. Buckminster fullerene is a type of fullerene, which is a molecule composed entirely of carbon. The discovery of fullerene is credited to Richard Smalley, Robert Curl, and Harold Kroto, who were awarded the Nobel Prize in Chemistry in 1996 for their work on this molecule. C60 is called a Bucky ball due to its shape, which resembles that of a soccer ball or a geodesic dome created by the architect Buckminster Fuller. The term Bucky is derived from the first part of Fuller's name. The structure of C60 consists of 60 carbon atoms arranged in a pattern of pentagons and hexagons, similar to the pattern of a soccer ball. The pentagons act as defects in the structure, allowing the ball to close into a spherical shape. The discovery of C60, also known as fullerene, was a significant breakthrough in the field of chemistry. In 1985, a team of scientists led by Sir Harry Kroto, Robert Curl, and Richard Smalley discovered C60 while studying the properties of carbon in space. They used a technique called laser vaporization to produce C60 clusters, which were then analyzed using mass spectrometry. The discovery of C60 and other fullerenes opened up a whole new field of materials science and nanotechnology. Fullerenes have a wide range of potential applications, from drug delivery and biomedical imaging to superconductors and photovoltaic cells. In terms of architecture, the geodesic dome designed by Buckminster Fuller is an example of a structure with a similar shape to the C60 Bucky ball. Geodesic domes are made up of a network of triangles, creating a strong and lightweight structure. They have been used for a variety of applications, from housing in commercial buildings to sports arenas and exhibition spaces. Buckminster fullerene was first synthesized in 1985 using a process called laser vaporization. This involves heating a graphite target with a laser in the presence of helium gas. The resulting vapor is then cooled rapidly, allowing the carbon atoms to form into the spherical structure of Buckminster fullerene. The discovery of Buckminster fullerene was a major breakthrough in chemistry, as it represented a new form of carbon that had never been seen before. It opened up a whole new area of research into the properties and potential applications of fullerenes. Now, let's move on to graphene. Graphene is also composed entirely of carbon, but it has a different structure than Buckminster fullerene. Graphene is a single layer of carbon atoms arranged in a hexagonal lattice, similar to a honeycomb pattern. This structure gives graphene its unique properties, such as high strength, flexibility, and conductivity. Graphene, one of the most fascinating and versatile materials known to science, was discovered in a somewhat unconventional way. The story of graphene's discovery starts with the humble roll of adhesive tape. In 2004, two scientists from the University of Manchester, Andrew Geim and Konstantin Novoslav, were experimenting with a type of carbon known as graphite. They wanted to isolate single layers of graphite to study their properties, but they were having trouble doing so using conventional methods. One day, while struggling to peel a layer of graphite off a piece of Scotch tape, Geim and Novoslav noticed something strange. The graphite layer on the tape was not only incredibly thin, it was also transparent. They quickly realized that they had accidentally isolated a single layer of graphite, which they called graphene. They went on to develop a method of isolating graphene using adhesive tape, which they called the Scotch tape method. To isolate graphene using this method, researchers start by placing a small piece of graphite on a piece of adhesive tape. They then press a second piece of tape onto the first, and peel it off. This process is repeated over and over again, with the tape being peeled off and reapplied to the graphite multiple times. Each time the tape is peeled off, it removes a layer of graphite, until eventually a single layer is left. This layer is then transferred onto a substrate, where it can be studied. Although the Scotch tape method may seem like a crude and simplistic technique, it has proven to be incredibly effective for isolating graphene. In fact, it was this technique that led to Geim and Novoslav being awarded the Nobel Prize in Physics in 2010 for their discovery of graphene. One of the most interesting properties of graphene is its electrical conductivity. Graphene is an excellent conductor of electricity, with a conductivity that is 100 times greater than copper. This makes it a promising material for use in electronic devices, such as transistors and sensors. Graphene is also incredibly strong and lightweight, making it an ideal material for use in aerospace applications. It has a tensile strength of over 130 gigapascals, which is more than 100 times greater than that of steel. This makes it incredibly resistant to damage and deformation, which is important in high-stress applications. Another interesting property of graphene is its ability to absorb and release gases. Graphene can absorb gases such as hydrogen and methane, which could be useful for storing and transporting these gases. So, tell me, how did you like this video? My idea is to keep you updated and ignite your interest in my subject, that is chemistry. Thank you for watching. See you very soon. Keep studying. The intellectual odyssey rages on. Thanks for watching.